So we can define a function as a relationship between two sets of data where each input has exactly one unique output. Inputs, we're talking about x values. It's what we put into an equation or into a function, as we're going to start calling it now. And an output is our y values. That's what we get out of the function, whatever input goes in. If cookie dough is your input and the oven is your function, what is your output going to be? Cookies, exactly. If cake batter is your input and your oven is your function, what's your output going to be? Cake, right? I always like to think of functions like an oven, because if you put cookie dough into the oven and you get out cake, it's not supposed to happen, right? So same kind of logic goes for our functions. Every input has exactly one unique output. Cookie dough's output would be cookies. If cookie dough could also have an output of cake, we'd never be able to predict what it is we're baking, right? Come on, guys. So we're going to be taking a look at functions from 4 different aspects in this unit: identifying, describing, evaluating, and comparing, as we see on our table of contents. Today we're just going to start with identifying. So we're going to be able to identify functions from 3 different situations. The first being ordered pairs. So with ordered pairs, let's say we've got 2, 1, 3, 2, and 4, 3. Our inputs are going to be in green here. Those are my x values. And what do we notice about those 3 inputs? They go in order, okay?
Order, but remember, the left it goes 2, 3, 4, and I feel like the right it goes 1, 2, 3.
Good. Okay, so we're just focusing on the left. What do we notice about these 3 numbers?
They're the same,
They go like the same, like 2, 3.
They're in order, right? Are there any of the same number there?
No.
No. So what we notice is that they're all different. You guys are noticing a pattern, which is great. Getting a little ahead there. But these numbers are all different. What do we notice about our outputs?
They're all in order.
They're all in order, but they're also all
different.
different. There we go, right? So we've got 3 different inputs with 3 different outputs. This right here is a function. We have no repeating inputs. So this is a function. Now technically we don't have repeating inputs with different outputs, but that's all we need to say is no repeating inputs. As soon as you see that you've got multiple of the same x coordinate in these ordered pairs, we know right away it is not a function. we take a look at another example, we got the points 2, 4, 2, 2, and 3, 1. What do we notice about these inputs now? There's a repeating input. An input of 2 giving us an output of 4, and an input of 2 giving us an output of 2. So, because we have repeating inputs,
It's not a function.
with different outputs, it is not a function. Right away, we see a group of ordered pairs. We've got different y values for the same x value. Like I said, this would be like putting in cookie dough and getting cookies, then putting in cookie dough and getting brownies. Right? If we're putting in the same thing, we should expect to get the same thing out. Not a completely different baked good, right? That's how we can tell with ordered pairs when we do have a function and when we do not have a function. Yeah, go ahead. With graphs, it's even easier to tell when we have a function and when we do not have a function. Let's take a look at an example of that. If we got a graph, we're not going to glue any graphs in. It doesn't have to be perfect. Where my inputs again are my x. My outputs are my y. I'm going to zoom in here. Hopefully we've all got those points down. And let's say I've got, ooh, that's blurry. Say I've got 5 points on my graph. Just like that. Remember, what we're looking for is repeating inputs, and inputs are my x coordinate. So if we look at these 5 points and we try and figure out, well, what are my x coordinates here? This first one's got an x coordinate right there. This second one's got an x coordinate right there. Third one, fourth one, fifth one. Do any of these points seem to have the same x coordinate here? No, right? So because no 2 points have the same x coordinate, also known as our input, we know that this is a function. So this graph here does represent a function. None of these points have the same x coordinate with a different y coordinate. Take a look at this second graph, this graph that's in red here. What do we notice about this graph right away?
It has 2 points that are the same x coordinate.
It has 2 points with the same x coordinate. This one lines up right there. This fourth one lines up over here. But both of these points line up right there. Let's say at 2, for example. But they have different outputs on the y-axis. That is not what we want. 2 points with the same x coordinate to put it in a more kind of easy to understand sense, we got 2 points. Oh, you can't even see it. We got 2 points that are stacked on top of each other. Whenever we see that on a graph, we know that this is not a function. If you see 2 x coordinates stacked on top of each other, or sorry, 2 points stacked on top of each other like that, that means they have the same x coordinate with a different y coordinate, which means it's not a function. We're almost done. We got one last thing. So those are our 2 graph examples. If we see a graph, even if it's not a straight line, it doesn't have to be a straight line. If all of our points have different inputs or x coordinates, then it's a function. If we have any points that have the same x coordinate, which means they line up directly on top of each other like this, it is not a function right away. These 2 points here in the middle would be like 2, 2 and 2, 3, which, as we know, when we're actually looking at the points, that does not represent a function. I'm going to leave this here for like 30 seconds so you can finish, because I got to flip over for the last little situation we're going to have here. Still writing, I'll come back to it. I want us to finish up here so we can get started on the IXL. Last thing we're going to talk about here is, let's do this. Mapping diagrams. Mapping diagrams are kind of like a table. If we were to look at one, it would look something like this. Got a little bubble of inputs on the left, bubble of outputs on the right. So we got inputs of 1, 2, and 3, and outputs of 4, 8, and 12. This is basically the same exact thing as a table, where the left side is your x, the right side is your y. And what you're going to see with mapping diagrams is these little arrows going from one input to one output. So because each of these inputs has exactly one unique output, by definition, this is a function. Right? If we put in a 1, we get out a 4. If we put in a 2, we get out a 8. If we put in a 3, we get out a 12. Each input has exactly one unique output. This is a function. But down here, let's say we've got an input of 6 that gives me an output of 1 and an output of 2. We've got an input of 7 that gives me an output of 3. With a mapping diagram like this, we have a repeating input of 6. Sorry. Repeating input of 6. That gives us 2 different outputs. One and 2. Therefore, this is not a function. So when you see 2 arrows coming from the same input to different outputs, right away we know that's not going to be a function, because if we put 6 into our function, we've either got to get out a 1 or a 2. We can't get out 2 different numbers for the same input. Tara's code. So that's our mapping diagrams. I'll zoom out there a little bit so you can see the difference. The key thing here is each input needs to have its own unique output. All right, that's all we're going to do today.